My name is Michelle Thompson, and I'm an associate professor in the Department of Earth, Atmospheric, and Planetary Sciences in the College of Science at Purdue University. I study planetary samples that have been brought back from other planetary bodies like the moon and asteroids. I analyze their chemistry and their microstructure to try and understand what conditions were like in the early solar system and how these planetary bodies have evolved over the last 4.5 billion years. Asteroids are really like relics from the early solar system. If you think about Earth, the surface is changing all the time. We have volcanoes, we have earthquakes, but asteroids have not been significantly altered since they were formed 4.5 billion years ago. So bringing samples back from an asteroid can tell us about the ingredients and the building blocks for the planets and life in the early solar system. It's important to bring asteroid samples back to Earth so we can study them in the laboratory. We have techniques and capabilities here on Earth that are just not possible to do with spacecraft, even if they're in orbit or if we have landers on the surface of asteroids. We do have pieces of asteroids that land on Earth, and we call those rocks meteorites. However, as soon as they enter Earth's atmosphere and land on the surface, they're contaminated by our atmosphere and by all the organic molecules that have evolved into life on the surface of the Earth. So bringing samples back from an asteroid allows us to understand which features are from the asteroid itself and which might be contamination from Earth's surface. The OSIRIS-REx mission is NASA's first asteroid sample return mission. It was also special because of the type of asteroid we went to visit. This was called a carbonaceous asteroid, meaning we expected there to be carbon minerals and carbon organic species on the surface of the asteroid. So studying these types of materials can give us an understanding of what the building blocks for life were like in the early solar system. These samples have been an absolute treasure trove of information. We've found that there is water in the crystal structure of some of these minerals, which can tell us about the distribution of water in the early solar system. We've also found organic molecules, which are the building blocks to life that could have seeded it here on Earth. And we have found interesting minerals like phosphates, which are really important for the development of life here on Earth. So finding those can tell us about the environments which might have been conducive to prebiotic chemistry early in the solar system's history. These results are so interesting because they can tell us about the conditions in the early solar system which could have led to the development of life here on Earth. If you think about life as a cake, we're not finding a cake in these samples, but we're identifying the flour and the sugar and the eggs that are all the ingredients that go into baking the cake. So it gives us clues about the recipe and the ingredient list for the development of life on the planet Earth. We are really just at the beginning of our journey in studying these samples from asteroid Bennu. They were returned a little over a year ago, and already we have an understanding of the distribution of water and prebiotic organic molecules in the early solar system. So I can only imagine what the next decades have to come in the analysis of these incredible samples.